Jessie Wilkins Jr. 4. Write 1 and 2 step functions. We are at the end of our study of functions for now. We began with figuring out what it was. We then learned to recognize them from a mapping diagram, a list, or a table. We then began to solve functions, 1 and 2 step functions. And now we are finally at the point where we need to learn to write them. Definitely the most challenging part of this section. But let's begin by reviewing vocabulary as always. The function rule is the rule that shows the relationship between the input and the output. You know that because you've solved them by now. The input, of course, is the x value, or what you put in to the function machine. The output is the y value, or what you get out of the function machine. The explanation for how to write a function rule is as follows. Your main job here is to see the pattern and then figure out how to make it a rule. So we start with a pattern. As you well know, I have shown you many of those, and we turn that into a rule. You've already been doing this and practicing this in class. There are a few steps that can help. The first step is to have a table and make sure the table is complete. The next step is to try to find, if you put in x equals 0, what would your answer be for y? If you can do that, if you can take the table and extend it so that that answer is either there, or you create the table to make it there, that will help you. You then look for the relationship between the y values, the relationship between the x values, and then together you try to figure out what the relationship is between them. Here's a visual. Looks a little crazy and a bit disorganized, but you will see soon that the best way to do these is to just write all over them and figure it out yourself. The more you write, the more it helps you to see it, similar to what we would do on the board with the patterns. You're looking to see what happens from one to the next. So if you look at the black numbers, those are the original values. This is the x, of course, and this is the y. And then if we look at the blue, we can see that it increases by 3 here, and then it increases by 3 there. For the y, it increases by 1, and for this x, it increases by 1. So it looks like that whatever happens to the x also happens to the y. That gives us our main rule, our relationship between them. So right now we know that that is 1. And then we have to practice a little more and do some more investigating to figure out what this extra 9 would be. And we do that by taking 3 backwards. So we would subtract 3 here, and that means we would obviously do the same thing here. If we subtract 3 from both of these, we get a 0 for x and we get a 9 for y, which tells us that if we add 9 to the x value, as this shows, we will actually get the y value. Okay, so lots of writing, lots of mess, but the more we do it, the more it'll make sense. There's one thing to watch out for that you need to be careful of. You do need to pay attention to how many the x and the y are skipping by. So for example, if you look at the red, if you jump from 2 to 5, that's 3. If you jump from 8 to 10, that's 3. And so we have to make sure we're paying attention to the jumps. Let's put this into practice in the examples. Example 1. First thing we need to do is calculate the jumps. 9 to 12 is 3, 12 to 15 is 3, 15 to 17 is only 2. Let's look at the x side. 2 to 5 is 3, 5 to 8 is 3, 8 to 10 is only 2. All right, well, what does that tell us? Well, it tells us that the x and the y are the same numbers, which means that more than likely we're looking at a 1 as the relationship, times 1. So you take your y value, you divide it by your x value, and you get 1. That means that the 1 will go in front of the x. Okay? So if that's the case, how do we know we're finished? But if I times 2 by 1, I get 2, I don't get 9. Well, then I can figure out the difference between that. I can take 2 and go backwards, and I can go take 9 and go backwards. That's going to leave me with 0 for x and 7 for y. So that 7 is what I started with. That's the piece that it began it all. And if I take this 2, this 5, this 8, and this 10 and plug it into this rule, I will see that it works. So let's take example 2. First, what's the relationship? Negative 2 to 2 is plus 4. 2 to 4 is only plus 2. And 4 to 6 is plus 2. Okay? And then 0 to 2 jumps 2. 2 to 3 only jumps 1. 3 to 4 only jumps 1. Take your y value, divide it by your x value, and you get 2. That means that the 2 is in front of the x. Okay? If I take that 2, put it in front of the x, and plug it in here where x is 0, 2 times 0 equals negative 2. So what do I have to add here? I have to subtract 2 to get that answer. That means that my extra piece, the piece that I would be adding, is minus 2. Let's try this one. 2 times 2 is 4, minus 2 is 2. Yes. 2 times 3 is 6, minus 2 is 4. 2 times 4 is 8, minus 2 is 6. That rule works for every one of the numbers on this table. Give this a try. You will probably need some help. I am here to help you. But the more you try, the better you will get at it. Like anything else in math, practice, practice, practice. Learn from your mistakes. Give this exit ticket a try and then check in with me.